Okay, so I want to have a little conversation about, does the fundamental of theorem of line integrals apply to that problem we did earlier, which was something out of 18.2?
Yeah.
This thing about the integral over a curve C of the vector field minus y comma x dr. So my first thought would be what?
Is it a gradient of something?
Yeah, I just want to know, hey man, is that a gradient of something? Right? If it is, then I can apply the fundamental theorem, right?
Yeah.
So I should be looking at this thing here and thinking that might be the partial of f with respect to x and the partial of f with respect to y. Yeah? Okay, so let me set that up. That'd be the partial of f with respect to x should be negative y, and the partial of f with respect to y should be x. So when we slap an integral dx and an integral dx on both sides of the x partial, so I should get something that should be about f, right? So I'm calling it f1. And it's going to be what? Negative xy plus some constant which depends on y, right? Okay, and out why not?
Because it's negative xy, and you can't make it negative yx over there. When you get the other one, you're gonna just get the xy.
Good, perfect. When I get the other one, right?
Yeah.
I get xy plus some x's.
It's just gonna be
You guys see that?
Yeah.
There's no way I'm going to be able to make these the same, right? Because, okay, so
They cancel?
these are supposed to be the same thing, right? Negative xy plus some function of y is supposed to be xy plus some function of x.
Or they?
Okay? So let me figure out what the cx is. That can't be cx, right? That can't be cx. Cx could at worst be a constant, maybe, so it can't depend on x. Let me figure out what cy has to be. Cy can't be that thing, so at best it could be a constant. Maybe c1 and c2, right? But those are constant.
Yeah.
Is there any way that, let me fiddle this around, c1 minus c2, right, should be what? 2xy. Is that going to happen?
No, they're constants.
No, that's a number. That's clearly not a number, right? That depends on some variables. Oops. Crash and burn. This didn't work, right?
Yeah.
So does the fundamental theorem apply to this thing?
No.
No, absolutely not. You cannot use it. What does this mean?
Does it mean
You have to parameterize, and it's gonna depend on which way you go. You guys see that?
Yeah.
So before I did this half circle, right? If I did this other half circle,
It wouldn't change.
it would change.
It would change.
It could change at least.
Oh.
You guys see that? If I knew that the fundamental theorem worked, right, then the path wouldn't matter, it would only matter about the endpoints. But here, because the fundamental theorem doesn't work, right, the endpoints matter, and how you get between them matters. Cool?
Yeah.
So, yeah, the path you take matters when you can't apply the fundamental theorem of, or the fundamental theorem of line integrals.
Okay.
Cool?